This is Antarctica, the southernmost continent on Earth. It is cold, virtually uninhabited, and is surrounded by the Southern Ocean. Antarctica is almost entirely covered in ice, which in many places is more than 4 kilometers thick. This is 43 times the height of the Statue of Liberty. It is by far the largest freshwater reservoir on Earth. If the ice cover melted completely, sea levels would rise by almost 60 meters worldwide. This would threaten coastal communities around the world. Ice in the interior of the Antarctic continent flows towards the edges of the ice sheet and in many places onto the ocean. When ice flows onto the ocean, it creates a suspended platform of ice called an ice shelf. These ice shelves are found around more than 70% of Antarctica's coastline. The two largest are the Ross Ice Shelf and the Filchner-Ronne Ice Shelf, both of which cover an area larger than Germany. Here, the ice is in direct contact with the surrounding air masses and ocean waters. Ice shelves play a crucial role because they buffer the outflow of ice from the continent's interior into the ocean, like gigantic corks made from ice. Over the last 2 decades, Antarctica has been losing mass at a faster and faster pace. This is mainly because deep warm ocean waters in West Antarctica have reached the ice shelves, leading them to melt from below. With further climate change, melting underneath the ice shelves will be amplified. As global warming continues, very small changes in the ocean temperature may cause the Antarctic ice sheet to cross what is known as a tipping point. There are 2 main tipping elements in Antarctica: changes in the Southern Ocean and changes in the internal dynamics of the Antarctic ice sheet itself. A tipping point is when a small change leads to a system crossing a threshold that leads to large and long-lasting changes. Imagine a set of dominoes. If one of them is tipped over, this causes a chain reaction. An example of such a tipping point has been modelled in the Weddell Sea. Here, changes in the Southern Ocean may cause density barriers, which currently shield and protect the larger Antarctic ice shelves, to be broken. This will allow warm water of up to 2 degrees to flush the cavity underneath an ice shelf. This could strongly increase melting, and in turn accelerate ice flow and global sea level rise. If a tipping point like this is crossed in Antarctica, it could lead to strong, long-lasting, or even irreversible changes. This could have consequences for coastlines and people around the globe. So what if one of these dominoes is set in motion? TiPACCs is an exciting new project funded by the EU that will assess the risk of crossing tipping points both in the Antarctic seas and the ice sheet. We will use computer models to estimate the likelihood of large and abrupt near-future changes in the contribution of the Antarctic ice sheet to global sea level rise. To find out more, visit our website and Twitter page.